So first and foremost, we're going to talk about how does tangential motion works. So there's actually two forces acting on it. The first one is tangential force, and I'm gonna explain it first. It is a force causing speed up or slowing down of an object along a circular path. And for the example, you can see on the video here. So for the second force, for the tangential motion, which is the centripetal force. So this force keeps the object moving in a circular motion by pulling it constantly towards the center. So for the example, you can see in the next video here.
So hi everyone, my name is Muhammad Shukri, and now I would like to talk about tangential velocity. So what is actually a tangential velocity? So tangential velocity is a velocity of an object that is moving in a circular motion. So tangential velocity, we can measure it using the formula, which is Vt equal to total S divided by total t. So Vt is actually a velocity and the small t is actually tangential. The formula is then the total is actually the displacement of an object in circular motion moving in a circle, and the total t is a time taken that the object take to reach its destination. So the SI unit for tangential velocity, we use the meter per second. And then moving to the next topic, what is actually the difference between tangential speed and tangential velocity? So the first one is tangential speed. Tangential speed is actually a scalar quantity. We call it scalar quantity because it only show a magnitude. So the value of the tangential speed is always positive, like 30 km per hour, 20 meter per second, and so on and so forth. And the difference is tangential velocity is actually a vector quantity. We call it vector quantity because it shows both magnitude and direction of an motion. So the value can be either positive or negative, based on the axis. So the value like negative 30 km per hour or positive 20 km per hour based on the axis. And then moving to the next topic, which is motion of movement, which is the first one is the clockwise moving this way, and the next one is moving counterclockwise this way. So the difference is in tangential velocity. The first one is clockwise, moving this one, so it's actually moving downward. So we're moving downward. So the direction of the tangential velocity will be negative, and the difference is with counterclockwise, which is counterclockwise is moving this way, like this, which is moving upward. So the value of the motion will be positive. That's the difference between counterclockwise and clockwise. So that's all from me. Thank you for lending me your ears to hear. That's all. Thank you.
Next, I will explain about torque. So what is torque? Torque is a measurement of the force which causes something to rotate around a point. So this is the formula for torque. How torque works? Imagine using a wrench to turn a ball. If you push harder, more force and more torque. If you use a longer wrench, it is a more distance and more torque. If you push at an angle, only the force that is perpendicular to wrench creates torque. So this is the explanation.
Think of a wrench and a nut which is seized up. Using a small wrench is very hard to free the nut. Using a long wrench will make it much easier. That's because of torque.
Hi everyone, now let's talk about the direction of torque. Torque isn't just about how much force we apply, but it's also about where and how we apply it. When a force acting an object causes it to rotate, it goes either clockwise or counterclockwise around an axis point. We know that the formula for torque is torque equals to force times radius. When rotating object counterclockwise, the torque is positive. Vice versa, when rotating object clockwise, the torque is negative. This helps keep our calculations consistent, especially when solving rotational equilibrium. For example, think of a seesaw. If someone pushes down on the left side, the seesaw rotates counterclockwise. That's positive torque. But if the force is on the right side, pushing down, it causes clockwise rotation, and that's negative.
Assalamualaikum and good evening. So my name is Muhammad Amri. I'm from Geology and I will be presenting about rotational equilibrium. So my slide will be referencing to this video on YouTube from Flipping Physics with the topics on rotational equilibrium introduction. So what is translational equilibrium? It is when an object is not moving or it is moving in a straight line at a constant speed, or simply when there is no net force. Next is rotational equilibrium. Rotational equilibrium when an object is not spinning or is spinning at a constant speed, simply when there is no net torque. So when the forces of when the spin is evens out. So next is torque equation. So torque equals to R radius, distance from pivot, times F, force times sin theta. And torque is the rotational equivalent of force. So rotational equilibrium defined when the net torque acting on an object is zero, causing the object to either remain at rest or rotate with a constant angular velocity. Is when object is not rotating or rotates at constant angular velocity. That means the net torque is zero. That's when they reach the equilibrium. So for real life example is a seesaw. A seesaw is a long balanced board that pivots in the middle. So the pivot point in the middle is called fulcrum. When two people sit on opposite ends on the chair, their weights create torque on each of their side. So when torques on both sides are equal or opposite, the seesaw is balanced, or in these topics is in equilibrium. But when one side pushes clockwise, the others will occur anti-clockwise. So when the torques are unequal, that's when we see the seesaw tilts. So that is how I explain rotational equilibrium simply. Thank you.